So we are going to look at this paper whereby we are going through Unit 4 Physics, IAL Edexcel. The first question, students were asked to state which of the following shows the electric field around a proton. So what you need to understand is that a proton is positively charged and is going to be considered as a point charge. So if we are talking about a positive charge and then that is a point charge, then it means that the fields are going to be radial and they are always directed away from the positive charge. So in that case, we are going to look for a diagram that looks like that. So you can see this one must be a negative charge. That's why the fields are coming that way. But this should be a positive charge. So the correct answer there is A. So, and the reason we are saying that is electric field lines around the positive point charge should be radial outwards, but for negative they should be radial inwards. And but for a current carrying conductor, the fields should be concentric, circular. So in that way, for instance, this is wrong because you see the spacing here. As you move away from the conductor, the strength of the electric fields keep on increasing. So for this case, if maybe the current was coming out of the page and you use right hand grip rule, the field will be looking like that. So currents coming out of the page and the field will be pointing in that direction. So something that you ought to remember is that the separation keep on increasing, which means that the fields becomes weaker as you move out of the conductor. So in this case, the correct answer that the examiner marked was supposed to be A. Now let's move to question 2. And question 2, we are told in the sun, two protons can combine to form protons. Two protons can combine to form a proton, a neutron, and another particle X. Which of the following particles should be X? So the reaction is P plus P, right? So proton plus a proton, we have a proton plus a neutron, then plus X. Okay. Which means that charge here, we have a positive charge because for reaction to take place, charge must be conserved. So this is a positive charge plus positive charge, and then we have here positive charge, and then this neutron is usually no charge, 0 has no charge. Then it means for this reaction to take place, we must have X having a positive charge. Okay, so charge must be conserved. So which means that the charge of Q, the charge of X is going to be positive 1. So that's one of the things that we need to point out. And we need also to look at the conservation of the baryon number. And since we are having protons here, we are going to say the baryon number must be conserved. So meaning the baryon number, in this case baryon number, before the reaction was 1 plus 1, and after the reaction we have 1 plus 1. The neutron, right, is the baryon number of a neutron is 1, so which means this must have a baryon number of 0. So because we are saying plus bx, so which means that bx, baryon number of x, must be 0. Therefore x is a positively charged meson. So we can be able to say x is a positively charged meson. Conclusion: is positively charged meson. So in that case, we can say the answer is D. And if you're new to Proflan YouTube channel, consider subscribing so that anytime we're going to upload more tutorials, you'll be notified. In Proflan YouTube channel, we do maths, and physics. So if you're taking pure math, you're taking mechanics, you are taking physics unit 4, 5, you'll be with me here for you to learn. Just consider subscribing. Okay, so moving to the next part, we are told in the next question that alpha particles pass through small thickness of absorber. The momentum of alpha particle is halved. The initial kinetic energy of the alpha particle is E. Which of the following is the kinetic energy of alpha particles? Which is the kinetic energy of alpha particles? So what is the first thing that we need to remember here? We need to remember a few things. Number one, that kinetic energy is given by the formula p squared over 2m. So that's one of the formula that we have to remember, where m is the mass of the particle and p is the momentum of that particular particle. So once we have identified that, we are told that alpha particle, if p is halved, what's going to happen? If p is halved, because the mass will remain the same, p is halved, so it means that we're going to have p over 2 squared divided by 2m, and now that is for instance, if that's the kinetic energy 2, yeah, so we shall just let it denoted with E2. So that's going to be p squared over 4 divided by 2m. Then if we want to get rid of this 4 that we have here, we are going to say times 4, also down here times 4. So if you work it out, you're going to get this being p squared over 8. And basically I can decide and write this as p squared over 4 2m. But remember, kinetic energy is given by p squared over 2m. Therefore, if the initial kinetic energy was equals to p squared over 2m, then I can be able to say p squared over 2m is E. So which implies that our new kinetic energy is going to be 1 over 4 times E, because the all of this part that we have at this point here, this part that we have here is basically E. So finally our answer now becomes E over 4, and E over 4 is, the answer is going to be B. The answer in that case is going to be B. So that is exactly what you were supposed to do in that particular section. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. These are questions that were tested in October, November. So as you are preparing for your May, June exams, all January exams, it's very key for you to go through the questions so that you get used to what and how the questions are usually asked. Which of the following is a scalar quantity? We're going to look at capacitance. Capacitance is a scalar quantity because it has only magnitude but no direction. Centripetal is a type of acceleration. Acceleration has direction. Impulse is a change in momentum, and momentum, all these they have what we call direction and magnitude, but capacitance is a scalar quantity because it has only size but no direction. So the correct answer there is A, which is a scalar quantity. We have question number 5. We are told that muons are unstable particles. Speed of approaching at speeds approaching speed of light. Actually, that is relativistic effect. This is going to change the lifetime and the rate of decay of muons. Which of the following is correct? Lifetime of muon increases and the rate of decay decreases. So we're going to say the correct answer for question number 5 in this case is going to be C. The lifetime increases but the rate of decay decreases. Yeah, because now they have a longer lifetime rather. So the correct answer there is C. We have question number 6, and let's see what it's asking us to say here. In this case, we are being told that when AC supply is switched on, an EMF is induced across the coil in circuit K. Which of the following could increase the magnitude of induced EMF? So the induced EMF will depend on a few factors. The number of turns in the secondary coil should be more. Also, we can talk of adding an ion core, yeah, which can be able to link the magnetic field. Then we can also talk of increasing the AC supply in the primary coil, which is going to increase the strength of the magnetic field which I created and linked to the secondary coil. Yeah, so those are the few. So let's talk of increasing the distance. This is going to decrease the induced EMF. So this is going to decrease the induced EMF if you decrease you increase the distance. Increasing the frequency of the supply, decreasing the number of turns in K. Yeah, this is going to decrease the induced EMF. Decreasing the magnitude of the potential difference. This is going to decrease the induced EMF. So the correct answer is B in that case. So B is the correct answer in that case. Yeah, well, that is great. Was a great question. And we need to look at question number 7, and question 7 says that a nucleus of carbon decays by releasing a positron. Which of the rows that show the proton number and nuclear number of the nucleus produced? Nucleus produced. So in question number 7, we are having, of course, carbon, which is having 11, and then we have 6 here. And in the process of decay, we are going to have another different element. And also we are told that a positron is produced, so which means that we have a positron being produced here. So the emission of a positron, in this case we are talking of a positron emission, so the proton number decreases by 1. So if we're going to look at that, we're going to say this is going to remain 11, but the proton number is going to decrease by 1. So here we shall have 5, because ideally here we shall have 0, and then we shall have positive 1 down here. So which means that if you have 5 here, it will mean that 5 plus 1 will give you the 6 that we were having at this given point. So what was the most important thing that you want to remember? We know that electron is usually written as 0, -1, that is an electron, but a positron, a positive, we are going to say this is going to be written as E is to 0 positive 1. Then now you can be able to write that equation. And now the correct answer, proton number is going to be 5 and nucleon number is going to be 11. So for question number 7, the correct answer is A, and that's what you are supposed to do in that case. Let's look at question number 8. We are told that in a cyclotron, charged particles are accelerated to high speed by applying alternating potential difference between two Ds. The alternating PD must have a particular frequency of the particles to be accelerated each time they cross between the Ds. Which of the following is the statement? Which of the following statement is not correct? Which statement is not correct? Now for question number 8, let's read the first statement. Yeah, so let's look at the first statement. The first statement says that frequency depends on the charge of the particle. Statement 2 says the frequency depends on the mass of the particle. The frequency depends on the velocity of the particle. So in this part, question number 8, frequency depends upon the velocity. Depend upon the velocity of the particle. And A is not correct because frequency depends on the charge. And remember, this question is asking us to identify what is not correct. So which means that A is true. Frequency depends on the size of the particle. Frequency depends on the mass of the particle. Frequency depends on the magnetic field flux intensity. So the frequency depends on the velocity of the particle. That one is the statement which is incorrect in this case. It's incorrect. The statement that is incorrect in this case is basically D. D is incorrect. And the reason as to why we are saying that is that frequency for cyclotrons, frequency is equals to BQ over 2 pi m. So you can see now frequency is dependent on the magnetic flux intensity, that magnetic flux density, the charge, which we can use capital Q or Q, and the mass. Yeah, so all these statements that we are having in this part are true because the frequency is dependent on them. But you can see from here, frequency is independent of the velocity of the particle. So the statement D, we can now agree and say it's incorrect. It's incorrect. Incorrect. Right, so let's dive in and move to the next part and get to see what the question is asking. A ball of mass m falls to the ground and rebounds as shown. The speed of the ball just before colliding with the ground is v, and the speed of the ball as it rebounds from the ground is v/2. The time taken for the collision is this. Which row is correct for the mean force acting on the ground during the collision? Mean force. What we need to remember is that Ft is equals to change in momentum, and change in momentum which we can call Ft is actually impulse. Change in momentum is final momentum minus initial momentum. Now in this case, if we take up positive and we take down negative, we can say that final momentum of this was the mass, let's say m, times v/2. That's the final momentum because the ball was going up at the speed of v/2, so mass times velocity, minus initial momentum, it was coming down, so let's take that to be negative. So this one upward we assign to be positive, so it will be minus negative mv. And then if you work it out, we are going to have Ft, and in this case our t is the time, which is change in small t that was given here, which is going to be a half mv plus mv. And if we simplify this, we are going to have our force being equivalent to 3/2 mv over change in t. And finally, we can conclude that our answer is going to be 3 mv over 2 change in t. So that's how we could have worked out that. But you can see now the force will be acting in which direction? The force will be acting. All right, so let's read which the speed of the, just before colliding, is that the speed of the ball as it rebounds is that as it rebounds, collision is that. Which row is correct for the mean force acting during the collision? During the collision, the ball is coming down. During the collision, the ball is hitting downwards, so meaning that the force will be acting downwards, and we're going to say the correct answer here is going to be C. So C becomes the correct answer. C becomes the correct answer for that. The particle moves at a constant speed in a circle. P, Q are two positions of the particle. The velocity P at P is Vp, because the velocity is tangential, yeah, and the velocity at Q is that as the particle moves from P to Q, there is a change in velocity, and the change in velocity in that case is going to be change in V. Now, which of the following is the correct vector diagram for the change in velocity? In this case, which one is the correct diagram for the change in velocity? So in this case, we are going to just use vector scales that we learned, so which means that so we need to identify a few things. P is considered to be initial because it's moving from P to Q, so P is initial point, and Q is final point. So whenever you are working out the change, you will realize that change in V is going to be what? Is going to be the velocity of Q minus the velocity of P, because we are talking of it moving from P to Q, so P is the final point, Q is the final point, P is the initial point, so we can be able to subtract it like that. So in this case, when we are drawing, we have now to check which one is going to ensure, or which one is going to display Vp being negative. So you can see here, the one that has Vp being negative is D. So the correct answer is D in that case.